And I guess we should start because it's only 10 minutes presentation for each, so we have a rough time schedule. Then a warm welcome to everyone to the Green Lean Digital session. Green Lean Digital means using lean methods and digital technologies to ensure more sustainable production and products. Thus, the diversity of these topics is large along the value-added chain. And however, we hear today exciting presentations in the areas of data acquisition, product design, product and manufacturing innovations, and logistics. The session will be moderated by Silvia and me. Maybe Silvia, you want to say a few words about you?
Yeah, from the industry side, I'm working for Festo. It's a company in the automation field. And what do? We build components for bigger machineries where they try to automate processes. So I'm very interested in what we will have for presentations today to learn more about what we can do in our business.
And I'm Andrea. I'm working for the Fraunhofer Institute Casting, Composite and Processing Technologies in Augsburg, and are there, among others, responsible for the planning and the management of sustainable production systems. So before we start with the first presentation, just one note. Please use the Q&A function on the right-hand side of the window to ask your questions. Silvia and I will ask them after the presentation to the presentator. And now we can start with the first presentation from Martin. Martin comes from the University of Stuttgart and is head of the Reliability and Driveline Department of the Institute of Machine Components. The research focused, among others, on live test planning, reliability demonstration, live data analysis, and reliability in driveline applications. Martin is supervising about 15 PhD students and 10 national and international research projects. As an expert in reliability engineering, holding also a reliability black belt, we are looking forward to your talk about connecting reliability and sustainability considerations in mechanical and civil engineering design to reduce oversizing without risking disasters. The stage is yours, Martin.
Yeah, thank you very much. I think you should already see my screen and can hear me quite good. Okay, perfect. Seems to work. Yeah, thank you very much for the kind introduction. And as it was already mentioned, my talk is about the connection of reliability and sustainability. So a little bit out of the box topic maybe, but as I will show you, this connection offers great new approaches in engineering design. So don't waste any time, let's get started. So for better understanding, we have to first take a look at one of the key challenges in reliability engineering. So in this very easy example, the task is to design a bus for transportation maybe, or something like this. And then we have a reliability requirement to ensure safe product operation or usage. And in automotive industry, requirements always look like, I don't know, 200,000 kilometers, 300,000 kilometers, something like this, with a maximum fraction failing of maybe 1%, 2%, 3%, or even 10%. So if we choose a design that actually meets the requirement, will always lead to high effort for reliability demonstration during the development process. The reason for this is that in most of the cases, the reliability demonstration is done using empirical data coming from live tests. And this data always contains a sample error, or in other words, uncertainty. Nothing else than uncertainty. So to minimize this uncertainty, we always need huge testing efforts. So a huge sample size and lots of testing time and effort. So a very, very common solution to this in reliability engineering is to use a design like this, so an oversized design, because if the design is much better than the actual requirement, the influence of the uncertainty is not that big deal anymore. But yeah, the other side of the coin is that we use a design that uses much more resources as it should, and therefore has on the other side a heavy impact on sustainability. So in summary, we have now a trade-off. On the left-hand side, we need the reliability requirement to ensure safe product operation or usage. And on the right-hand side, we need the sustainability to face the oversizing problem in design. And yeah, you might already know what's going to happen right now. We need them both, in my opinion, to identify an optimal product design for individual engineering problems. So I brought for you today in my short presentation 2 examples, one from the mechanical and one from the civil engineering domain. And this one is a very easy one to get familiar with our new designing approach. So this one is the designing process of a gear wheel. And a very critical parameter for the designing process of a gear wheel is the tooth width. So the challenge is now to design the teeth that we can actually meet the reliability requirement, which was in this easy example 99%. Otherwise, a failure like this one here, so tooth fracture, will occur too early or too often. So the main challenge is now to identify the best design that meets the reliability requirements, but in combination with minimal global warming potential. So in the designing process, as I already mentioned, we have to consider that we have to demonstrate that our product actually meets the requirements. And in 99% of all industrial application, live tests are used for this kind of problem. We also, for the impact on sustainability, we also used a life cycle assessment where we considered the effort due to reliability demonstration and also for the planned sailed units. As a result, we get a chart like this, so the global warming potential over the chosen gear width. And as you can see right now, we get 3 curves. So one is for the effort due to reliability demonstration, as you can see it right here. One for the GWP coming from the planned sailed units. And the third one is showing the combination of them both. So we can now take a closer look at the results. What is happening right here in the blue circle? This is exactly the case, what I mentioned on the start of my talk. These are actually very good on-target designs, so very, very small chosen gear width. But you can, as you can see, for reliability demonstration, which is shown right here, so fraction of failing over lifetime, we need huge testing effort to actually be able to demonstrate the reliability requirement right here, to keep that uncertainty in the dashed line here small to be able to demonstrate the requirement. This dashed line here is called the confidence interval. This is the method we use to quantify the uncertainty. Yeah, and this will lead to high global warming potential. On the other side, if we use an oversized design, we have significantly less. We need significantly less samples and testing time. To give you some numbers, a design like this with a chosen gear width with 7.8 millimeters requires 600 samples for reliability demonstration and a total testing time of about 100,000 testing hours. If we go up a little bit with the gear width of 8 millimeters, we only need 500 samples and only a testing time of about 3,000 hours. So huge difference in in global warming potential. If we further increase oversizing, and here you can see what happens if we use oversizing, the GWP of reliability demonstration goes down, but the GWP due to the planned sales units goes up, so increases. And this is only a very small gear width, and that scales with the mass of the system. Just keep in mind or imagine what's going to happen when you use a calculation for a whole transmission or even a whole car. Then maybe the slope of the straight is very, very steep and not that flat anymore. Yeah, and this chart at the end is the perfect basis to identify different key results for the design process. We see at first an absolute minimum. A smaller width is not even possible because due to the uncertainty in the reliability demonstration. But we can also use this kind of calculation. We have also a no-go zone, so this is not even possible. But at the end, we want to identify our optimal design. And this is the one with the minimal global warming potential, and that is able to demonstrate the reliability requirement. So it is possible to find an optimum like this. And if we compare this result with the German engineering standard for designing gear wheels, we see a result like this. So with a safety factor of 1, this is located in the no-go zone. And the recommended safety factor of 1.2 is located in the oversized zone. So, and not only a little bit in the oversized zone, as you can see it here with 11.1 millimeters of chosen gear width. So maybe we have to face the fact that standards, that actual use standards, misses the optimal design totally. And maybe one have to keep in mind that we need an update of these standards, maybe. Okay, my second example in the short time period is from civil engineering, and here we have also quite similar problem due to huge resource consumption and to produced emissions. We see here we need an increase in sustainability, but yeah, as well, we want to have the same reliability because no one would like to live in a building that is not that safe as a common one right now. So we need also decrease in sustainability, but at the end with the same reliability. Here we at the Institute of Machine Components are part of a German collaborative research center funded from the DFG. And the main idea here is to integrate actuators in the load bearing structures to dampen the loads due to maybe wind or earthquakes or something like this. And the idea is then that we can reduce the necessary cross-section of the bearing structure and so decreasing the material consumption. The main challenge here, as I already said, is also the identification of the best possible design in terms of reliability and sustainability. So we designed different variants with actuators in the first module, going up to the 24 actuators in the third module. And the basis for the load calculations was a representative load spectra here in Stuttgart from the weather station here in Stuttgart-Vaihingen, where the actual demonstrator was built. So, and this was the basis for the lifetime calculation, respectively the damage calculation. This is the result for the reliability calculation. I'm not going deep into detail because of my time limit. I also saw the yellow card. But the most important curves are these one right here at the bottom, because these are the unavailability in combination for the critical load, which is in this case the occurrence of a heavy hurricane. And in our case, it was chosen operating time for the demonstrator of 10 years. And as you can see, all of the variants fulfill the requirement, which is this black line right here coming from the European guideline for designing bearing structures. So we are fine for that. And at the end, we also used a life cycle assessment in combination to calculate the global warming potential for the different variants. And as you can see right here, this is the reference, the totally passive structure with the total global warming potential of about 3,000 kilograms CO2 equivalent. And as you can see right here, we can have huge savings in global warming potential due to the mass reduction and the damping functionalities due to the actuators. So I don't know, what is this, a little bit under 800 kilograms CO2 equivalent. Some of the savings are actually getting compensated by the use of the actuators itself or the actuation energy that is necessary. But yeah, this is not a big deal anymore. So, and another beneficial effect is that you can see it right here on the right hand side with the relative lifetime calculation. This is the reference stated with 1 for 10 years of useful life. And as you can see, due to the damping functionality, even with the reduced mass of the structure, the load-bearing structure will last the 2.8 times of the reference structure with the passive version. So huge benefits in reduction of the global warming potential, and also a much more higher lifetime. So to sum my very short presentation up, as you can see, in reliability engineering, we have always the problem that we get rid of all the reliability problems using oversizing. Yeah, but that at the other side uses much more resources as it should. And as you can saw in my two different examples, I think only the consideration of them both helps us to find very optimal designs for engineering processes or in engineering applications. So yeah, I'm at the end of my talk. Thank you very much for your attention. Thank you also for my colleagues and from the colleagues from Gabi, which did all the LCA calculations for us. And I'm glad to answer your questions. Sorry. Thank you.
Thank you, Martin, for the interesting talk and the interesting presentation. We've got in total 3 questions, I see. The first one from Alexander. It's about the global warming potential of the gear. He asked, does the GWP minimum also go hand in hand with the cost minimum? Have you ever evaluated the costs?
Yeah, this is nearly the same result. Depends a little bit what you actually take into account for the cost calculation, but yeah, at the end, global warming potential is very, very familiar with the arising costs from the problem. Yeah, so yes, to answer this in one word, yes.
Thank you. Then we've got another question from Miguel. Is it possible to assess reliability with different methods in a way that we can have savings in greenhouse gas emissions without compromising safety?
In one word, yes. Because yeah, as I showed in my example for right here in the very abstract way, because that in reliability engineering we always address the uncertainty with a so-called confidence interval, you never loses the relationship to safety. So yes, actually you are able to address a reduction in global warming potential even with the same safety level. You always have the, let's say, the related parameter with the reliability target, because when you say, okay, you want only a fraction of failing of about, I don't know, 1.5%, sorry, 0.5% or 1% fraction failing, you can design the product like this. But as you saw it in this example, yeah, the standards we use produces results like this. So this is hugely, highly oversized. So most of the problems in safety and reliability is not that too many products are actually failing. It's more or less too much oversizing. So yes, it's doable. You can do this using reliability techniques.
Okay. And another question from Luisa. Do you address the possibility of longer lifetime because of over-design, and which could lead to positive sustainability effects?
Yeah, very good question. Very, very, very good question. I have to admit, we haven't addressed this problem yet, because the chosen useful life is a very, very heavy influencing parameter. And there are so many different impacts on this problem to get answered that we haven't any time to address this problem yet. So, but this is actually one of the next steps we're going to do in the project from the civil engineering domain. Yeah, but sorry, cannot answer this one.
And when do you think are you done? Then we can see the results.
Yeah, we started right now with the second phase of the project funding. So I think maybe in the next year would be a good time period. Maybe on the next conference, I can talk a little bit more about this detail. Maybe. Yeah, but this is a very interesting question, and for us also, but not that easy to answer.
Thank you.
Okay, thanks.
Thank you all.
So the next one is as a presenter Daniel Wehner, but unfortunately I have to tell you Daniel in person will not present us his slides. We will see a video, but we also have a representative from the Institute who will for sure answer the questions you have after the video. But give Daniel, also if he's not here, a chance that we maybe shortly introduce him. He is also working for Fraunhofer Institute, but he's working for the Fraunhofer Institute IBP. Daniel has graduated at Nürnberg Tech, and he's holding a doctorate in environmental engineering. And what is he doing at the Fraunhofer IBP? He leads the development of the data science powered product stewardship and corporate sustainability solutions for industrial companies. So he's focusing on efficient systems that are tailored to individual business roles and seamlessly integrated into their workflows. And in the presentation, he will introduce the sustainability data science life cycle, which is an approach where you have workflow automation for LCA-based multi-purpose portfolio analysis. So I'm very interested what we will see now. So I guess Tobias, you will show us the video.
Hello and welcome everybody to my presentation on workflow automation for multi-purpose LCA of large product portfolios. In the Fraunhofer IBP host session on Monday, we already mentioned the sustainability data science lifecycle, basically an implementation of two applied data science approaches in the product stewardship domain. This presentation will actually introduce this approach and its implementation for workflow automation. But first things first, why do we actually need such an approach? Pragmatically, because increasing regulations and stakeholder requirements call for scalable LCA application, as sustainability management departments have to ensure compliance with an increased number of requirements, legal requirements on the one hand side, but also to answer quickly rising numbers of client requests for environmental data. Last but not least, if you want to drive sustainable change in your company, this cannot go without multiple internal stakeholders, because in the end, they are the ones making the decisions and drive change, and they probably also have the data and the domain knowledge you need in order to come up with robust and actionable LCA results. So there is a clear business demand for scalable LCA solutions. Looking for a solution, we looked at the problem from another perspective than just LCA, the data science perspective. LCA itself is great, but actually was never intended for portfolio analysis. Hence, it is very cost intensive to scale up. From our experience, this is mainly because it makes us focus on single products and kind of forces us in a very slow product by product scale up loop. And it also wants us to find or best measure the data you need in order to answer a particular question, again, forcing us into a very slow iteration loop. The data science philosophy significantly differs in these two aspects. On the one hand side, it's open for any kind of business problem to be solved with data. And it is designed to make the most out of available data, which is, of course, a much faster iteration loop than the one I just mentioned. Last but not least, it focuses on making results available as digital solutions instead of just long reports. So there's reason to believe that we can learn something from applied data science approaches. And good news, LCA and the cross-industry standard for data mining, CRISP-DM, they're basically a perfect match, as they're both structured in phases of a data analysis project and suggest an iterative approach for stepwise improvement towards analysis goals. The rather new data science lifecycle additionally picks up on the CRISP-DM and adds a particular focus on further practical aspects of operationalization. So we integrated these three things, CRISP-DM, the data science lifecycle, and LCA to what we now call the sustainability data science lifecycle. In the center is an infinite loop of creating insights through data, the creation cycle on the left, and coming up with solutions in business, the deployment cycle on the right. This is basically as in the original DSLC. Outside, you see particular steps for implementation in the sustainability domain. We will publish a full description of all steps after the conference in a related paper. And in the limited time we have today, I want to point out three important aspects covered in this approach. First, many different sustainability related problems always need to leverage similar data. However, the validity of the data may get old very quickly as new entries are made to the database, etc. So it is not enough to collect data once, but you will need to do it on a regular basis and therefore need highly efficient means to access this data. Second, with the tools, you might, for example, have already seen in our host session, it is somewhat easy to compute results for 100,000 of different products. So coming up with a large-scale LCA results of potentially millions of data points and the basis for deep insights into your product portfolio. But making conclusions out of such a large solution space may be pretty different to what one might be used to in traditional LCA of a single product. Data science tools and techniques provide you with functions for visualizing and interacting with large solution spaces, as well as for the identification of correlation and patterns. Third, when it comes down to driving sustainable change in business, one of the most common mistakes, in my opinion, is overloading business users with a lot of all the cool things we figured out in the explore and analyze phase, trying to make them understand all the little details we figured out at this time. So in the customize and capture phase, it is not about making nice diagrams out of large LCA results and making them available as a dashboard. For example, it's rather a common fail. It is about taking a step back again, looking at what it really needs in order to improve a particular business process to drive sustainability, and what of the newly gained insights have to be captured in an automated workflow that supports this improved business decision process. So let's look at an implementation example helping to improve, for example, a procurement or supply chain management process. Procurement departments work with suppliers, they select them or engage with them in a particular way to somehow improve the collaboration. So in terms of sustainability improvements, they might want to know what of the things they can do has the greatest impact in terms of sustainability. And they might even want to know this considering changing sales trends, because this has an impact on what needs to be sourced in the future. To answer such questions, you need to bring together data for current sales, for sales trends, bill of materials, sourcing data, and of course also LCA data. This is how an automated workflow could look like. This one pulls data from an ERP system and an LCA database. It integrates data from sales, from product design, from sourcing and LCA. It computes the LCA results on item level and provides custom but different interactive views. On the one hand side, for the LCA experts dealing with the vast solution space, helping them to do the quality control of the incoming data and so on, and other visualizations tailored to the particular business users. All built based on reusable building blocks for data access, cleaning, lifecycle impact assessment, and all the things you would need for all kind of LCA applications in business. And these building blocks are in particular very useful, as one will certainly come across typical data challenges in the practice of dealing with a large number of data with high variability and velocity, or even when essential information is only available with certain individuals. On the right-hand side, you see a very simple example how to capture such knowledge that is only available with individual in an automated workflow using the so-called rule engine. For more complex problems, you could also go, for example, for decision trees or more advanced modeling techniques you can find in professional data analytic tools. Based on such workflows, you can then build a set of role and task specific dashboard tools or web browser wizards that can easily be updated with new data from the enterprise core data systems. In this example, it is a dashboard to rank suppliers by sustainability level on product portfolio level that allows for exploring the impacts and of changing sales trends. To sum it all up, the sustainability data science lifecycle is an approach to workflow automation for multi-purpose LCA of large product portfolios, improving the scalability of product stewardship and corporate sustainability. It caters for the demand coming from having to deal with increasing regulations and requirements from multiple stakeholders to drive sustainable change. It integrates LCA approaches with approaches from applied data science and is, in our case, applied for automating data processing and analysis workflows, as well as to drive sustainable change by enabling non-sustainability experts, business professionals with tailored digital solutions. And that's it from me for today. If you want to know more, you're very welcome to reach out to us or to follow us through our social media channels. Thank you very much.
Okay, so thank you. We got, I guess, 3 questions. We had some problems. We were a bit wondering if the video was, let's say, stuck, but we saw that he was remaining on one slide a bit longer than on the other ones. So let us start with the first question. This one came from Caroline, and she asked, how much effort is it to build up the connections or the match of LCA data with ERP data in complex production networks?
Well, thanks for the question, Caroline. I think it really depends a lot on the size and the complexity of the ERP system. So what we've seen is that basically with every client that we applied that to, we had different complexity of the data and also different data systems where they have their data warehousing or they have dedicated tools for certain different things. What we try to do before really doing a multi-purpose LCA by using that data is checking the data readiness first. So that is our first step, and it's crucial. If you're interested in an industry application, I will have a talk later with Alexander Shevelov from WE.1.E, where we applied that on their portfolio. And what we've seen there is that in their portfolio, they had different tools for different so to say information on the different products, and we had to integrate that first. This is a very common thing because bigger enterprises usually don't keep all their data in one location specifically. So yes, there is a lot of work, but also that can be automized. And the beauty of the approach is that you can reuse that. So once you've created that approach, they won't change their enterprise resource planning every 2 weeks. So you're most likely able to use that in a few years again, or in a few months, or whenever data needs to be updated, products have changed, or the background data for your lifecycle assessment has been updated. And we also split the LCA calculation from the data preparation so that if something changes, we just have to address one of those issues.
Mm-hmm. Okay, so thank you. There was another question from Eric. Oops, sorry. Can you elaborate on how you did the mapping between the BOM as it means the source data and the LCA data. The slide mentioned mapping algorithms by experts, but some more context would be helpful.
Yeah, I understand that. I mean, you have to press it into a few slides, so it was not very into detail. Maybe I can use the project I was mentioning earlier as an example again. Again, this depends a lot on what kind of bill of materials you have, where the data comes from, and what kind of mapping you need to do. But basically what we did is that we had an Excel export. So it was a structured data set of around 4 million cells in an Excel file. And with an algorithm, we were checking for different columns of that file for different types of information. And you're basically searching for fragments in there. For example, if you have a column that's called material, and they really specifically explain what kind of material where it's sourced from, and there's a lot of information in there, and you just want to know, is it steel or is it brass? Then you would just use fragments of that text and search for those and map them accordingly. So that's basically the algorithm. On that scale is pretty small. So you just search for keywords and you map according to the keywords to, in our case, Gabi data sets that we exported. But in theory, you can use any lifecycle assessment databases for that mapping.
Okay.
And maybe one more thing added, we worked that in KNIME. So we just used files, imported them into KNIME and did the entire workflow there.
Okay. So another question came up. What portfolio LCA would need from LCA databases? Are features missing in LCA databases?
Well, what we need is basically unit processes, for example. We're taking the environmental impacts for a unit process, so we know how much the production of a certain type of steel in a certain region of the world has as a global warming potential and different other impact categories. So basically that's what we're exporting into KNIME, where we model further. Are features missing? I guess that's the same as for any LCA analysis. Obviously, you never have exactly the process that you need, and you have to make a lot of mapping and assumptions there. But in general, it works well. You don't have to change anything about the structure of the data sets to use it.
Okay. Very sorry, but we have to hop to the next one. And I guess maybe Mark, Oliver, you could ask Tobias after the session about how long it takes to put this in place, because I guess it depends on. So please stop the discussion right now because we have to hop to the next one.
Thank you very much.
Tobias.
Thank you. Yeah, once again.
Once again, yeah, Tobias is presenting the next slides. Tobias is now we introduce you, that everyone knows what you're doing. Tobias is a project manager also at Fraunhofer IBP and a research associate at the University of Stuttgart. He works on the quantification of environmental impacts of advanced materials and product systems, ranging from single elements in the development stage to large portfolios, as we heard already, of more than 100,000 market-ready products. In particular, the scalability of established LCA approaches plays a key role in his work. For the past 4 years, he was deeply involved in the assessment of functional nanomaterials and printed electronics in 2 Horizon 2020 projects. Today, he's going to talk about how to accelerate sustainable development and production of nanomaterials and printed electronics.
Thank you very much for the introduction. I hope my slides are up and running. And I'll just get started directly. For those who feel like they don't really know what printed electronics is, bear with me. I'm going to get to that just as a start. Basically, there's a huge hype that we've seen. As I was introduced, I've been working in 2 Horizon 2020 projects in the last years, and we've seen there's a lot of hype around this buzzword of printed electronics. It's basically printing electronic circuits in an additive process, and you end up with something that looks like this. So I'm not sure if you can see my picture very, very well, but it's basically, it's a flexible circuitry. This one is a temperature sensor. It's transparent, so you can see through it where there's no circuitry, and it's really low cost, high speed manufacturing due to the reduced complexity. So the three biggest advantages over conventional electronics is that you have those flexible and lightweight thin substrates, sometimes even stretchable. You have really low cost production because the complexity of manufacturing is so much lower if you just deposit the material where you want it, and then you have one after treatment step instead of conventional electronics where you coat an entire area, you mask it, you develop the mask, you remove unwanted excess material, you remove the mask, and then you end up with the final product. And that also makes it very material efficient. Of course, there's also challenges and obstacles. I mean, it's not the savior technology that's going to change the electronics industry completely. I picked out three that I've been observing, which is there's a lot of gaps in knowledge. So there's a lot of potential users that we've seen or that have been identified by project partners, but they don't even know what they could benefit from printed electronics. And also they have no idea about the manufacturing processes because they're not into printing technologies. On top of that, it's really difficult to get access because due to the low market penetration that we're observing, you also don't have the visibility for test facilities, especially in Europe, whereas Asia and the United States are much bigger markets for that. And what for me as a sustainability analyst hurt me most is that the assessment is always just about does it function and what does it cost, and we're seldomly talking about sustainability. And if we even do that, it's just qualitative assessments like, yeah, it's better than conventional because we're not using all those etching chemicals, which is great, and we're not producing a lot of waste. And obviously we have to look a bit deeper into that. And I want to go into the potentials for sustainable development of printed electronics. Basically, this diagram, some of you might know it already. It's basically describing how the increasing knowledge about the design from a problem over idea to the implementation of a technology increases, while at the same rate, the design degree of freedom decreases, which is pretty obvious as a concept because the more you select as definite selections and specify properties, the less you can really change it. Accordingly, the potential for sustainability improvement decreases, which means we should be around the ideation phase to really get engaged with the assessment of printed electronics if we want them to be sustainable in the long run. So to sum up that quick introduction on printed electronics, I did a small SWOT analysis, which just highlights the four most important aspects. The biggest strength is definitely that this technology allows you to do things that you can't do with conventional technology. So if you're looking at that, I could never bend a circuitry made on a printed circuit board, just as I did with that one. The weakness, on the other hand, is that there are so many specifications that are unknown. Even experts don't really know how to apply it, how to achieve certain functions, and this is really a big problem in the industry as well. But then again, it leaves us a big opportunity because we're still on the left-hand side of that graph, so we can still influence the sustainability performance of those devices and that technology in general. But the point is we have to act very quickly there because there's more and more applications that are being rolled out. And it's a similar thing as what Martin mentioned earlier. It's just about the sheer mass. If you scale that up, if you think about printed RFID transponders put on every Coca-Cola bottle, that would add up to something like 0.3% of the entire silver production that we have in Europe at the moment for one application and one use case. So we shouldn't miss the right moment to engage. And this is basically what is the entire idea of the project that I'm working on currently. We have possible users that are interested in the technology, but they need a multi-perspective assessment to evaluate if they can use printed electronics or if it makes sense. Then they need easy access to pilot lines because you need to try it out and you need to really see devices to know if it works for you. And in the end, you want some knowledge transfer to use it further in the future. And that's basically, as I said, the idea of LEBED. The project is called Innovation Testbed for Development and Production of Nanomaterials for Lightweight Embedded Electronics. And what we're doing basically is we provide a holistic one-stop shop for expertise and infrastructure access for everything that's concerned with nanomaterials, formulations, and printed and embedded electronics. And we split the project up in 3 parts, which is the phase 1, where we evaluate, the phase 2, where we prototype, and in phase 3, we deploy the solutions. And what we've seen regarding the sustainability, the clients we had and the business partners, they had always the same kind of 6 questions when they were thinking about how to implement that on the long run. And this was, can this solve the problem that we're thinking about? Is there a market and a business case for that? How environmentally friendly is it? What competitors are there? What's the market situation? Is it safe to work with that? Because we're talking about nanomaterials in the production process, and how can we finance the whole thing? And that is basically what set us up for what we developed in phase 1, as we call it, which is a set of different services. It's a multidimensional assessment before we even start the production. And this is key if we want to achieve sustainable printed electronics, because otherwise, if we have something in the market or being prototyped already, it's most likely not going to be adapted for sustainability reasons in the long run. What it does, the service that we provide is we cover the entire value chain, because there's there's a lot of different stakeholders in there. So we need to make it suitable for any previous background, and we have to make it highly adaptable so people can really get involved, no matter if they know about printed electronics or not. I don't want to go too much into detail with the customer journey. Basically, it's just there's a simple contact with an initial idea. You run through the phase 1 assessment, which is split in 2, where we just say go or no go from a technical and economic perspective, which again, I said that in the beginning, as a sustainability analyst, always kind of makes you consider, isn't it more interesting to look into the other parts as well? But we determined that sometimes you can even fail just by answering a questionnaire. You can fail an idea and reiterate it. And after we have the assessment results, we go through phase 2 and 3 that I mentioned before. So the 2 main questions that remain with printed electronics, or that are asked often, is how can an early evaluation even be a sustainability enabler? And this is what I just said. We really need that fast fail of unpromising ideas and a swift restart of ideation, because it is a great technology and it can be sustainable, but it really depends on the applications. That's why we consider sustainability holistically and from the beginning of the ideation phase, to avoid allocating resources to a project that doesn't even have a chance for implementation. And what is, in my opinion, a really crucial part is to also build knowledge and awareness in the industry, because there's not a lot of sustainability analysts around there. And on the topic, how can printed electronics be sustainable in general? Due to the time, I think I'm going to skip that, and I'll just tell you that there has been another presentation, and there's currently a publication in review that I published with my colleague Florian Gehring. And it's basically just summing up what we found is relevant. So to my last slide, it's not only in theory, we already put that into practice. So in LEBED, we already developed a few prototypes after a successful phase 1 assessment, where we ensured that the sustainability is possible with that applications. And one that is really exciting for me, just to pick one out, is Swarovski, where you can see that you can see a thing, because there has been developed an ink that is conductive, highly conductive. It works to power those LEDs, but you can't see it at all. And I think we will see more of those exciting applications of printed electronics, but I really urge to follow the path that we started, to holistically evaluate it just from the beginning. If you're interested in more, you can find the link. That's it from my side. Thank you very much.
Thank you, Tobias, for the interesting presentation. We've got one question from Miguel. are printed electronics easier to recycle? Is this one topic?
Fantastic question. I will keep it short. No, not at all. Because you have a kind of trade-off. It's good for the production phase because you use less material. So in the LCA study, the production phase would come out to be more environmentally friendly. But the end of life typically ends, what are you going to do with a device like this? It ends up in the household trash. This contains 23 milligrams of silver nanoparticles. They are gone. And that is the biggest challenge, that you have a lot of dissipation that we have to assume is going to happen. So that's the short answer. Longer answer, I would refer you to my paper or hit me up in the chat function and we can discuss this further.
Thank you very much. Another question. You've got different targets in the assessment. What are you doing when the opposing targets appear in your in the evaluation?
This is a great question that we've been discussing internally in the project a lot. What we decided to do is that we create this, what I call the fact book, which is a transparent communication of all the positive and the negative aspects, and we deliver it to the client. So we, as the developers, obviously there's some parts in there, some parties that want to sell their products, their technologies. They're not going to say it's bad. So we kind of leave the decision to the user. But we communicate also the negative aspects really clearly and also deliver no-go decisions. So if we say this is absolutely critical, you should not be going forward, then this is a clear suggestion. But in the end, the decision, I can't answer the question you originally asked because the decision is not made by us.
Okay. Thank you.
I also have a question. What would you recommend smaller, medium enterprises or grown companies, how they can start this process? Do they have to scan their product portfolio and find out where they can use the nanomaterials or the printed electronics? How they could start the process? What do you think?
I think there's different ways to get started. Well, one way is obviously to research projects like LIBET, where, for example, we have 10 of those phase 1 assessments that are free of charge, just offered to people that might have an idea. But basically, it starts with the interest. So what we've seen is that the industry partners, they really have a strong drive, and they say we really want to go into novel technologies, and they're kind of pushing into every field that they can find. I don't see it as a replacement technology for many things. So I rather see it as a brainstorming, what can we do additionally that could be interesting for companies? Because it's not the same as conventional electronics. The functionality simply isn't at the same level.
Okay, so thank you. So I guess there are no questions left. So thanks, Tobias, for taking part for 2 presentations. And the next presenter is Simone. I'm sorry for speaking it maybe wrong. Simone is giving us a next presentation, and let me short introduce him. He started studying life cycle assessment solutions for the manufacturing sector at the National Research Council in Italy. But right now, actually, he is now pursuing a PhD program at the National University of Singapore, and I guess you're based already in Singapore at this institute for manufacturing technologies. And today he will show us a preliminary results from his project that will deal with the IoT-enabled dynamics of LCA and LCC. So this is your stage. And
thank you.
We are really interested in your presentation.
For the kind introduction, just I check that you're seeing my screen.
Yes.
Perfect.
Okay, let me go on. Okay, yep. Today I will be talking about IoT-enabled hotspot analysis with dynamic lifecycle inventory. Before we begin, just want to acknowledge my collaborator Ishi and my supervisor Siram and Jonathan. Okay. Okay, hotspot analysis is something that LCA practitioners deal with it like almost on a daily basis, and we can look at what are the major impacts in terms of what is the major process driving impact, what is the major technological flow, so electricity, natural gas, or environmental flow. Is it CO2 emissions or methane, for example? And then we can change this assessment based on the impact category that we are interested in. And visually, we can look at it through Sankey diagrams or more analytically through a contribution tree as reported here. However, here I want to talk about a new approach for hotspot analysis, and this would entail the use of dynamic data. But why do we bother? Like, life cycle assessment is already complicated, it's already complex. So why do we bother using dynamic data? Well, because as we can see from this image, if we manage to understand if we have some kind of variability in our process, and if this variability is reflected in our impacts, in our daily impacts in this case, then we may want to study those days in which we are emitting less, even though we're not that. No, we didn't really know that. So the research question that I want to tackle today is how to systematically perform hotspot analysis using dynamic lifecycle inventory. So in this study, we will, ideally, these are very preliminary results. So it's very much more than a prototype rather than preliminary results. But ideally, dynamic data collection through IoT would enable dynamic LCA, and we would keep constant lifecycle impact assessment coefficients. So in this figure here, we can see how different processes end up into a final product, as normally we represent in a lifecycle assessment. But here we also have another dimension, which is time. And so the longer the process box, and the longer you can expect this production to be. And you can see how process 2 and process 3, they start in the same moment, and so their production partially overlaps. And this is an example of what could it be their impact, one LCA impact over time. And again, as we can see that process 2 and 3 overlap, their impacts are stacked one on top of the other. Well, so now let's dive into the systematic approach that we're trying to develop. And so the first step is to select an LCA impact category. And then we look at this graph that we are looking just in the slide before, which is the LCA impact over time. And we start looking at the peaks of this graph. How do we do that? So we have a decreasing selection threshold, so this red horizontal line that slices our impacts, and we only select the part that is above it. And as we lower the selection threshold, of course, we will select more and more area, which means that we are selecting more and more impact. And every time that we select and we change the height of the selection threshold, we can select a different beginning and start of these over time for the hotspots that we are interested in and that we are focusing on. The next step is to order the contributions that we have highlighted by the largest area under the selected peaks. Of course, the largest area here is the overall LCA impact of this between this time. And we can see how, for example, the impact of the yellow process that was not even present in the first iteration is now more significant than what was before already present here, this second peak. The next step, again, is to control which share of impact that we are selecting, summing the impacts of the overall peaks compared to the average product impact. This is to give us an understanding of, okay, is this a hotspot? Is this like 10% of their whole production, or are we selecting pretty much everything? Because like maybe if we are selecting 90% of the products with a very low threshold, this is not very significant and we don't want to get there. The next step is to check if there are simultaneously contributing processes in the selected time span. So here we can see in our example, the blue and green processes are stacked one on top of each other because, as we have seen, they produce at the same time. And so, yes, we have to repeat this process, this time diving in this time span. So starting from here, and as we can see, we can then assess that the blue process is actually more impacting than the green one. This is because the considered area of the LCA impact is higher. Okay, then once we have cleared that, then we can go into further detail. What is it that we need to look next is what are the LCA driver, one or more if we have. And so we can repeat again the operation with lowering the threshold again. And we can then also assess whether the impact, in this case, in this example, we have the impact between from two different life cycle inventory contribution, which is electricity consumption and natural gas combustion. And we can see that since this the area from electricity consumption is higher, then within this process, this is a more relevant impact. Finally, what we want to understand, and which could bring a lot of potential for improving our process, is to compare our production with different production cycles and compare it also with, for example, here, as we see with the average LCA impact. Further consideration that we want to take into account are the number of production pieces that we are allocating. So, for example, some processes might work in batches, but this number of batches might not be constant, and we have to take this into account for allocation purposes. And again, for allocation purposes, something that is very important to take into account are the discarded products, for example, for quality concern. And this is because, of course, if a product is not has to be discarded for quality concern, that the related impacts have to be reallocated to other products. Coming to a conclusion, this is a streamlined approach and a very simplified case study, but I just wanted to give you an idea of the systematic approach for hotspot analysis with dynamic LCI. The limitation that we have here is that since it is a streamlined approach, this means that we can only look at the variability in the foreground, which is the foreground is by definition impacts that we have control on, so those that we can measure dynamically. This is good and bad because we usually don't have availability of the variability of the background system by definition. So we don't know, for example, how long ago did we extract the raw materials that we are consuming. And so it is important to keep separately, to keep track of these two components in order to understand which is the share of our impacts that is truly variable, that we are truly considering. Potential advantages of our approach is that, yes, we are able to look at a closer look within the process. And so, for example, we could look at what is the impact of, I don't know, turning on an oven, which is something that usually you would not see in if depending on the aggregation of your process, modeling. And another thing is that since we simplify the use, like I think that as LCA practitioner, of course, we are quite used to these Sankey diagrams and contribution trees, but I feel that it is much easier to understand graphics over time, and so we might need less specialized workforce to understand what we're doing, which is good because, I mean, it's not good for us because we make a living out of it. I'm finished, yes, but of course, it's good if you want to speed up the transition towards greener impacts. And yeah, this is my email, and I thank you all for listening and attending this interesting session. And yeah, I welcome any question.
Okay, so thank you very much for your presentation. There's a question from Miguel. The question is, how are you implementing the calculation of dynamic LCA inventories and scores? As far as I am aware of common LCA software, they do not do this feature or do not have this feature.
Sorry, can you repeat the question?
So how are you implementing the calculation of dynamic LCA inventories and scores? Because what Miguel says is that he knows that such common LCA software does not do this feature.
Yeah, so in the first iteration of our work, we will work with simple Python implementation. I think that the next step would be to also within Python, we would like to work with the WE.1.E framework, now 2.5, because that could enable some flexibility, and it's more interesting, more difficult to model maybe, but it could be more resourceful in the long run.
Okay.
So Python.
Okay. I also have a question, and I would like to make a connection between presentation we have seen in the session, between your presentation and the one we have seen before, the one from Daniel. So what are the most likely differences between Daniel's approach, where we come from this portfolio-based LCA, and your approach? Or do you see connections between these two approaches?
I don't think so. I think that the granularity of the data that we're looking at is quite different. So I think, for example, here, like this approach was taught for example, a factory shop floor, for example. So I don't know if it could be applied to a portfolio, because, like, of course, like complexities, the level of complexity is very different. So I'm not sure I'm able to answer this question. Sorry.
No, don't worry. That's interesting, because you would focus on the shop floor level, and we would get some data, and he would focus on the product portfolio. The question is, could be there an interlink between both of them? I guess, yeah.
Yeah, I guess that they could work like in sequence, maybe. So once we highlight what is the main contributor portfolio-wise, then we can zoom in more into detail. Mm-hmm. Of course, this requires collaboration between players, data sharing, trusting issues.
Okay, so in the chat there was like a hint from Miguel to the poster of a dynamic LCA, but I guess we do not have further questions. Or Andrea, do you have a further question for Simone?
No, I'm fine. I think we go on with our last speaker, with Hanna.
Thank you,
Warm welcome.
Thank you.
Thank you, Simone. Welcome, Hanna. Really glad that you made it into the session, because I think you're chair of a parallel session today.
Yeah.
Just a short introduction. Hanna is working at the Research Institute RISE, Research Institute of Sweden, and got her PhD from Chalmers University of Technology in Sweden. Her work focused, among others, on environmental life cycle management, circular economy, and sustainable business. Today, Hanna talks about a research project implementing IoT in a Swedish municipality. I hope I got it right.
Yes, thank you so much. Could you see my full screen at this point?
Yes, perfectly.
Perfect. Okay, but I don't see you, so just so you know, I see only the presentation. Thank you so much for the presentation. So today I will present then a project called Inclusive, Sustainable and Connected Society, which is about IoT, Internet of Things implementation in a Swedish municipality. And so as we know, the strive for sustainable development is as needed as ever. And with that, we have the Sustainable Development Goals, we have the Green Deal, the strive for a circular economy, these are all things to direct efforts towards a more sustainable society. But in parallel, we also have the digital era, which provides new means of using then, for example, open data, sensors, or Internet of Things. So in Sweden, then, a progressive municipality are trying to combine these two areas with digitalization and sensor data with resource management, with the goal then of reaching net zero emissions of greenhouse gases in 2030. So in Södertälje, then, this municipality, they have a proof of concept project, which is kind of the background for the current project I'm presenting, where they have tried out an IoT system on 160 trash cans, where they have added sensors. And the idea with doing this is to be able to enable route optimization and to then measure degree of filling of waste in these trash cans. So the current project, the Inclusive, Sustainable and Connected Society, we want to further explore this type of proof of concept and see how machine-generated and open data based on sensor store could create insights used for both internal efficiency, such as higher resource and cost efficiency, but also to use that type of data sources as a support for citizen dialogue and inclusiveness regarding sustainability goals. So currently we are finalizing step 1 in this project, which focus on the current state of analysis, and where we have used interviews, study documents, conducted an internal workshop, and also did a LCA of this proof of concept with the trash cans and sensors. So I will now, in short, present these 3 areas with preliminary results. So for the first area, environmental impact related to the waste collection, we see that the waste collection contribute approximately to 12 tons of CO2 equivalents per year. And this is actually mainly due to the trash bags that is used, because the trash bags are exchanged then when you empty the trash cans. So here, actually, the IoT system has an insignificant impact in comparison. So we see that there are good opportunities to reduce consumption of the trash bags and also workers' time spent on the waste collection by using sensors on these type of waste collection system. With regards to preliminary results related to digitalization in Södertälje related to resource management. We have seen in interviews that there are quite a heterogeneity in the perspective, where users and needs and capabilities related to digital technology are quite divided within different units. So it can work well within one unit, be very specified there. But then we see that it becomes more of these isolated beneficial tools and systems, but that there is a possibility of more strategic coercion and oversight between systems that are used within different units within the municipality. And we also see a bit of this phenomenon where IoT or Internet of Things is seen as a new problem to address rather than new means of addressing old problems. So with regards to the current state of analysis, current state regarding the citizen dialogue in Södertälje, we have seen that they use different forms to communicate with the citizens, surveys, interviews, but also more type of information campaigns or dialogues related to, for example, building plans. They've also used hackathons and have ongoing plans for a citizen app as a way of also reaching citizens in Södertälje. So overall, we see that there is much awareness of the need of communication and the need of including many different interest groups in society. For example, in Södertälje, it is quite a broad diversity of language that are spoken, for example. But we see also that a lot of the activities related to citizen dialogue are based on operational needs. So more when a need is identified, then they act on it. So we see that there is, again, here more possibilities of having a more coordinated and strategic approach to the citizen dialogue. Overall, we see that the respondent voice that there is possibilities overall with more shared practices and collaboration between different units. So in all, with this, what we see now in this project is that machine-generated open data can provide a lot of possibilities to share data with citizens. Also that there are a lot of already functioning IoT systems today. There are quite a lot of focus on sustainability and the need to act there. And there are also an active citizen dialogue, but a challenge or then an opportunity is actually to bring all these aspects together to have a more coherent approach and strategic approach. So next in this project, we are going to look at more, other type of concepts developments that could be used in Södertälje. For example, where sensors are related to reuse or, for example, more related to recycling. And with that, we're also going to continue to combine that with an environmental assessment, as well as looking at a citizen dialogue related to these type of concepts development to ensure that the concepts that we are looking at are actually something that citizens are interested in and see the value of. So with that, I would like to thank you for listening, and maybe you have some questions now, or feel free, of course, to contact us after the conferences. It will be very nice to hear your views. Thank you.
Thank you, Hanna, for the nice talk. We've got 2 questions I see so far. From Joachim, I hope I pronounced it right. Have you or are you going to take into account impacts caused by data transfer and storage? And if so, how do you are taking them account? The IoT system cannot function without the mobile network and servers.
Yes, good question. I will see if I can respond to that. But basically, the studied system now is a cradle-to-grave system, which included both raw materials, sensors, gateways, the use phase, the end of life of the sensors and gateways, as well as the internet connection and the cloud services. So I'm not sure if that totally answers the question. Otherwise, I think we might also have a Birgit, a colleague of mine, the project present, if I didn't respond correctly.
No, I think thumbs were up, so I guess that was the correct or the answer he wanted to have. Yeah, and Brigitte says also, I think we have included this. Perfect. Then we've got another question from Stefan. He asked if you have further application possibilities in mind for these kind of project settings.
It's maybe I can answer in two different ways. One is that they are looking at different sensors already now, but which might not so related to resource management. But other types where they're looking into is, for example, sensors to be able to show whether parking lots for handicaps are occupied or not, or having sensors on this type of what do you call it, life rings you can throw out into the water if someone is in an emergency. But in the project related to resource management, as I mentioned, we've looked into little bit so far on reuse and recycling. And for example, they have these recycling stations where they also started to have small houses where you can put in objects for that can be reused. But there they don't have so much statistics, and they could use more data to see how much actually do they get in and how much products could be reused, what is kind of the statistics there, as well as things related to how many people are entering the recycling stations, when is it much people there now, if I should go there or not. So these are some of the aspects being discussed, but we will go more into that quite soon in the project to do this kind of overview and see which concept would be worth exploring further.
Quite interesting. Thank you. Silvia, do you have another question?
I have a question, but this is more like has to do something with the mindset of the citizen. What I understand, if you analyze all this information and you maybe know how much garbage they produce, the question is, do you have to train them or support them with the information that they know what happens in the city? Did you think about something like this?
It's a very relevant question, and both. Let's say one thing is that we will, when we do this new type of concept development, that we try to engage citizens in that to see like whether or not these are relevant or not. But we also want that the citizens should know the environmental data so that they can actually act upon it and know like could I decrease my environmental footprint or not, for example. But I know that they have had a lot of issues in the municipality with the correct sorting. So they've said that there are a lot of information and effort needed to actually educate citizens on how to sort correctly and what kind of consequences it can get if you do a more correct sorting or if you maybe do not the correct sorting. So it's probably a combination of education and dialogue.
Okay, interesting. So thank you.
Thank you very much.
Thank you very much to all speakers. I think we had a really nice and diverse talks today. Quite interesting. Before we got to the end of this session, we got already the hint of Miguel. I just want to share you, if I can. Maybe Silvia, I just don't find the button at the moment. No, okay, then I just say it. We've got 2 posters which are dealing with this topic, Green Lean Digital, as well. One poster is from Marianne Süße, The topic is an extended maturity model to integrate digitization and sustainability-related measures in small and medium-sized manufacturing enterprises. So if you are interested in this, just have a look, or recommend a look on that poster. And the other poster is from Miguel. We chatted this already. The topic here is the life cycle assessment of cognitive manufacturing applied to energy-intensive industries. I think, thank you to everyone. I hope it was interesting for you, and enjoy the last sessions in the LCM 2021. Silvia, you've got some...
No more words to say. Thanks a lot for all the presentations. It's very interesting.
Thank you very much, everyone.
Thanks. Bye-bye.
Thank you very much.
Bye-bye.
Bye.
Bye.